Hi everyone, let's start with the concept for today. We will be understanding how to calculate the forward rates from the spot rates, not by using the formula, but by using the timeline method. So this is going to save us the trouble of remembering one formula from the text. Now just to do a quick recap, let's try to remember what the forward and the spot rates were. Now spot rate is essentially any rate which is available to you in the market right now. So if I want to invest for 2 years, 3 years, 4 years, or 5 years, starting from today, that rate is what is called as the spot rate. So that is an investable rate. I can go into the market, put my money into the market and actually be able to earn that rate. The other concept is the forward rate. Now the forward rate is essentially a theoretical rate, and that's why we also call it as the implied forward rate. So this is the rate which we will be calculating today. Now, why are we calling it as a theoretical rate or an implied rate? The reason is because this rate is supposed to be the interest rate in 2 future time periods. So let's say, what would be the rate between year 3 and year 4 if we are at time period 0 right now? Now, we need to understand that these are only projections, these are only forecasts. So based on the current spot rates, we are trying to calculate what would be the implied forward rate. Now, this is not an investable rate unless you lock in this rate using a derivative such as a forward contract or a future contract. So in order to make it investable, you will need to go in for a derivative. Till the time you do so, it will remain only an implied rate, which means that this rate may or may not exist in reality between year 3 and year 4 when you actually reach that point in the future. So in order to lock that rate, you will have to go in for a forward contract. So that's what a spot rate and a forward rate is. So spot rate is the rate available if you invest your money right now. Forward rate is the theoretical rate of financial transactions which might take place at some point in the future. Now, implied forward rate, which we are actually going to calculate, is the break-even in reinvestment rate, which you calculate using the spot rate. Now, let's understand what the timeline looks like. 0 is today, the time period right now. That is where you're agreeing on what the forward rate is going to be. Time period T, the small t, is the point of investment. So let's say you want to invest your money starting 2 years from now for a period of 1 year, which means between year 2 and year 3, if we look at it from today, which is time period 0. So that would be the point of investment, and T plus R would be the maturity. R, let's assume, is 1 year for now. So time period 2 and 3, 2 would be the small t. T plus R means 2 plus 1 year, which is 3 years. Now, how do we calculate the forward rates? First, let's look at the formula. Remember, formula is not the focus. We want to actually calculate, we want to actually get rid of the formula. We want to do this using a timeline. So we will have a look at the formula so that we are able to compare both the methods and so that you get convinced that we are going to end up with exactly the same formula without actually memorizing it, even if we use the timeline. So let's look at the formula which has been given in the text. So that's your formula. So 1 plus ZA raised to the power of A into 1 plus IFR. IFR stands for the implied forward rate between time period A and B is equal to 1 plus ZB raised to the power of B. Now, what is the ZA and ZB? A refers to the shorter maturity. B refers to the longer maturity. ZA and ZB refers to the respective spot rates for the shorter and the longer maturity. Now, what do we mean by the shorter and longer maturity? Like the example which we were taking, if we have to look at the rates between year 2 and year 3, the shorter maturity is 2, the longer maturity is 3. So we will require the spot rates for year 2 and year 3, and that is what we are going to put into the formula here to calculate the IFR. Remember, IFR is the unknown rate. That is what we are calculating here. So let's try out an example. Now you're given the following spot rates. The 1 year spot rate is 5%. The 2 year spot rate is 6%. What do we need to determine? We need to determine the 1 year forward rate 1 year from today. Now you'll see several different kind of notations here. Main thing is that you understand that which rate exactly are we calculating. So first, let's put everything into the formula and then we do this exact same question using the timeline method. Now, if we look at the formula which we just did, that's your formula. Remember, A refers to the shorter maturity, B refers to the longer maturity. Here, the shorter maturity is 1 year. The 1 year spot rate is 5%. So that is A. The longer maturity is 2 years. So that is B. So 6% is what we're going to use for ZB. 5% is what we're going to use for ZA. This is going to give us the forward rate 1 year from today, because the difference between the two is 2 year minus 1 year, which means exactly 1 year. So that's your formula. Let's simply put all the figures that we have in this formula. So ZA is the 1 year spot rate, which is 5%. The 1 year forward rate at time 1 is the unknown rate, and that is what we are calculating. On the right hand side, you have the 2 year spot rate, which is 6%. Now, one thing to remember, and you should always do this check, even in the exam, even if you're, whether you're using the timeline method or you're using the formula method. So this essentially helps you avoid any calculation errors which could be there. You need to look at the powers on both the sides. So you have raised to the power of A here, raised to the power of B minus A here, and raised to the power of B here, which means just add up the powers on both the sides and they will always be equal. So that's a quick check which you can do in the exam whenever you're solving this kind of a question. So here we put all the figures that we have from the question in the formula, and this is what we get. We have 1.05 raised to the power of 1 plus 1 plus f, which is the unknown rate. That should be equal to 1.06 square. We simply input all the figures. Now the point which I was mentioning, that to double check, just add up the powers on both the sides. You have 1 here and you have 1 here. You add that up, you get 2. On the right hand side, you also have 2. So this is always going to be true in case of calculation of forward rates using spot rates. On the left hand side as well as the right hand side, add up the powers just as a quick check to make sure that you're doing it correctly. Now once you do this, your forward rate comes out to be 7.0095%. Now make a mental note of the expression that we ended up with here. In this case, we had to put everything into the formula, so we need to memorize the formula. Now when we do it on the timeline next, you'll see we'll get to the exact same thing using the timeline method without memorizing the formula. And that is exactly the purpose of this video. So keep a mental note of this. So in this case, how did we calculate the forward rate? You have 1.06 square. You take 1.05 raised to power 1 on the other side, and from that you can subtract the 1. Now let's try doing this using the timeline method. Okay. So if you want, you can just pause the video right now and try to draw the timeline on your own and then check with what we're going to do here. So it's the same question which we have, 5% for 1 year, 6% for 2 years, and we need to determine the 1 year forward rate 1 year from today. Now let's look at the timeline. You have 0 here, 1 here, and 2. I'm sure all of you would be knowing how to draw the timeline by now. It's a very important concept in finance, not just for a particular course, but in finance generally. You use it everywhere. In quants, you use it for derivatives pricing, equity valuation, fixed income valuation, as well as, calculating the forward rates. So the concept of timeline is something which you have to do everywhere. So I'm sure you would know how to work with this by now. All right. Now getting back to the question. 1 year spot rate is 5 and 2 year spot rate is 6. So first, let's just plot it on the timeline. First, let's look at the 2 year spot rate. So 6%, that means from 0 to 2, it's 6% here. Then the 1 year spot rate is 5%, which means this is 5% here from 0 to 1. What do we need to calculate? We need to calculate the 1 year forward rate 1 year from today, which means this part is what we're calculating, and that's your unknown rate F. So we are denoting that using capital F. Now what we're going to do is we are going to use the principle of no arbitrage to calculate these values. Now what do we mean by that? Now no arbitrage means it does not matter how we go from point 0 to point 2. We should end up with exactly the same amount of money in our hands. Which means, let's say, if we were to invest $1 for 2 years at the rate of 6%, or if we were to invest $1 for 1 year at the rate of 5%, then collect that amount and reinvest that for another year at the rate of F, which is the unknown forward rate, the future values in both the cases will be exactly the same. So essentially what we're going to do is we are going to create two different expressions and we're going to equate that. So we calculate the future value on the lower root here, and then we calculate the future value on the upper root, and then we equate both of them to calculate the F. So let's try doing this. So if we take $1 to start with and we compound it for 2 years at the rate of 6%, what do we get? We simply get 1 into 1.06 raised to the power of 2 because it's for 2 years, and that gives us 1.1236. Okay, that is the figure which we get on the lower root. Now let's see what figure do we get on the upper root. Now let's do exactly the same thing, which means on the lower side we took $1 to start with. Similarly on the upper side we also take $1 as the present value, as the principal amount. Now let's invest $1 for 1 year at 5%. What would you get? You would simply have $1 into 1.05 raised to the power of 1. That is the amount which you end up with here, right? At this point. Now this is what we are going to reinvest for another year at the rate of F, which is the unknown rate. So we take this amount, whatever we have, then we invest for one more year at F. So what will we end up with? We are essentially taking this and we are investing at the rate of F for another year. So that is what we get on the upper root. Now the next thing that we have to do is essentially equate both the expressions, because we know that our future value is going to be exactly the same regardless of the route which we follow. Whether we go from 0 to 1 and then 2, or we go from 0 to 2 in one go, we need to end up with the same amount of money. So in the lower root, we got 1.1236. We simply take that value and we equate it to this root which we just saw. So this is the expression which you end up with. Now, all that you need to do is to calculate F from this particular equation. Now that's easy to do. You have 1.1236 here. Take 1.05 into the denominator here. That will give you 1 plus F. From that, subtract the 1, and that will give you this value, which is 7.0095. So that's all that you need to do. And this expression which we got is actually exactly the same expression which I asked you to keep a mental note of in the previous slide, where we use the formula to get to this. So that's how you can use the timeline to calculate the forward rate without memorizing the formula. Okay. So now what we're going to do is we're going to try out another example, an extended example. So let's see. Now you have example 2. We assume annual discrete compounding. We need to calculate the implied forward rate between year 2 and year 3. Now the reason why we are extending the previous example is because in almost all likelihood, if this particular question was to come up in the exam, it will not be in the format which we just did. That was only to make you understand the concept. Normally, in the exam, you would be getting 6 or 7 different rates. You would be given a tabular format such as this, and you would be asked to calculate the rates, the forward rate between 2 different time periods from that table. The biggest problem which students face in such a question is that they're not able to figure out which rates to actually use for the calculation. And that is why we're doing this question. Now you need to calculate the implied forward rate between year 2 and year 3. And we have the rates given for year 1, 2, and 3. We have the spot rates for all of these 3 years, right? Now, which rate do we actually use? Similarly, instead of this, I could have 1, 2, 3, 4, 5, and 6 as well. So out of the 6 rates, which rate do you actually use? That is the question. Simple answer to that, we need to calculate the rate between year 2 and year 3. So those are the only 2 spot rates which actually matter to us, which means year 1 rate, even though it has been given to us, is irrelevant. We're not going to use it at all. We're simply going to use the year 2 and year 3 rates. Had you been given 4, 5, 6, even those rates are something which you simply ignore. So now let's try doing this using the formula which we saw earlier. So again, B is the longer maturity, A is the shorter maturity. The longer maturity is 3 years, the shorter maturity is 2 years. So 1 plus 3 year spot rate raised to the power of 3. Similarly, 1 plus ZA would be 2 year spot rate raised to the power of 2. And IFR is your implied forward rate, which is the unknown rate which we are supposed to calculate in the question. Now that is raised to the power of 1. So your forward rate would simply mean that we have to rearrange this equation to calculate the 1 year forward rate. So 3 year spot rate is 11%, 2 year spot rate is 10.5%. So your forward rate comes out to be 1.11 raised to the power of 3 divided by 1.105 raised to the power of 2. Remember, that is going to give you 1 plus F. So to calculate F, you need to subtract 1 from the other side. And that gives us 12%. Now, remember what we said about double checking the final answer that you get. Let's try doing the same thing here. Let's look at the powers on the left-hand side and the right-hand side. On the left-hand side, you have 3. On the right-hand side, you have 2 plus 1, which means we've done it correctly. So this is always a check which you should have in your solution. So remember this point. Now let's try doing this question using the method which we are discussing, which is the timeline method, so that we don't need to look at the formula. Again, just pause this video and try creating the timeline on your own first. Okay. All right. Again, the same data, the same question. We need to look at the rate between year 2 and year 3. So in this timeline, I've just removed year 1 because that's not relevant. So it does not confuse you, right? So you don't need to use 1 anymore. I don't need to put 10% anywhere on this timeline. The only rates which matter to us are the 10.5 and 11, which is the year 2 and year 3 spot rate. So for the 3 year spot rate, just like what we did in the previous question, we take it to 11%, which has been given to us in the question. So that is on the lower root. Similarly, on the upper root for 2 years, it is 10.5%. And the next one is an unknown rate, which is F. Now, what you need to be careful about here, and that is the reason why we extended the previous question, is now this is the 2 year spot rate. So when you're compounding, remember to take the time period as 2 here. So that is a very common error which people make, is that they ignore the powers. And of course, the answer that you're going to get is wrong in that case. So be very careful about putting 2 in when you're raising it to the power, the first expression when it is being raised to the power. All right. Now let's follow the same no arbitrage method that we did earlier. That regardless of which route we take to go from 0 to 3, we will end up with exactly the same future value. So we start with $1 here. We compound it for 3 years at the rate of 11%. And what do we get? 1 into 1.11 raised to the power of 3. Similarly, we take $1 on the upper root. We compound it once till year 2. So that means you have $1 into 1 plus 10.5% raised to the power of 2. Now that is something which you need to reinvest for 1 more year at the unknown rate, which is the F. So this is again being compounded, and that's the future value which you end up with. So $1 into 1.105 square into 1 plus F1. So make sure you do not forget this bit, that you have to square it. Okay. Now again, going by no arbitrage, the future values which we got have to be exactly the same in both the cases, which means we can equate this future value on the upper root to the future value on the lower root. Now, once we do that, and just another point to mention, I hope by now you've realized that the $1 which we assumed initially is actually immaterial, as long as both the values are the same, because it is going to get cancelled out anyway. So whether you take $1, $10 or $100, it does not matter at all, because it's the same figure on both the sides. So it is going to cancel out. Okay. All right. So now all that we're doing is we're going to equate both the future values. So the expression which you end up with is 1 into 1.05 square into 1 plus f raised to the power of 1 will be equal to 1 into 1.11 cubed. So these two future values. From this, in order to calculate the forward rate, all that you need to do is get F on one side and put everything else on the other side. So that's how you do it. So 1.11 cube, 1.105 square goes into the denominator. Again, you've calculated 1 plus F. So in order to calculate F, you need to subtract the 1 here. And that again gives you 12%. That's exactly the same answer that you got using the formula as well. So once you have the timeline, just plot everything on the timeline and you'll be able to do it directly. You will not get confused with the powers which you have to use, which you might get confused with had you used the formula, because sometimes people end up confusing the Z expression, which spot rate goes on the left, which spot rate goes on the right. They confuse that when they're using the formula. That is not going to happen if you use the timeline method. So I strongly recommend that forget about the formula, stick to the timeline, because this is already something that you know. Just stick to this method and you'll be able to calculate the forward rate. So that's it, guys. I hope you found this timeline method useful, and this is what you're going to use in the examination. Thank you.